Hey Navajo Nighthawks, this is Module 5, Lesson 20 and 21. In this lesson we are going to be adding fractions that have related denominators, related units. So it might not be the same denominator, but they're going to be related, which are going to allow us to make equivalent fractions with common denominators. In the first couple problems, we're going to be using a tape diagram as our visual model, and then we're going to see what that looks like with a number line. And then kind of our goal by the end is to be able to do it without a visual model. So our objective is I will be able to use visual models to add two fractions with related units using the denominators 2, 3, 4, 5, 6, 8, 10, and 12. Okay, so for our first problem, we have 1/4 plus 1/8. So notice my denominators are not the same, but they are related, right? We can say, well, 1/4 I can convert to eighths because 4 times 2 gives me eighths. So I can rewrite this addition problem as 2 eighths, which is equivalent to that 1/4, plus 1/8 is equal to 3 eighths. So we just changed one of them. The 8 stayed the same because when we're adding, remember the rule is our denominator stays the same and we just add our numerators. Well, if I have two different denominators, that doesn't really make sense, right? I'm not going to say, well, that's 2 4/8 because I have a 4 and an 8. So that's why we need to convert to make our units the same before we add. Okay, so if we were to use a tape diagram, I'm going to draw 2. Well, that's not very even. It's a little better. So I'm going to draw 1 to represent each of our fractions. So first I'm going to represent 1/4. And then I'm going to represent 1/8. Okay, and then if I were to decompose this 1/4 a little bit, or into eighths, then we can see that relationship between our fourths and our eighths. So I already have fourths. So if I decompose each of those one time, that's going to give me 2, 4, 6, 8, and I have 2 of those shaded. So 1/4 is equivalent to 2 eighths. Okay. All right, let's do another one using that tape diagram model. Okay, our next problem is 1/4 plus 1/12. So this one I'm going to start with the tape diagrams. I'm going to draw 1 for each fraction. So I'm going to represent 1/4 first. And then I'm going to represent 1/12. Okay, so I have my 1/12 and my 1/4. So we are going to look at our denominators and say, are those related? Can I convert one of them to be the same as the other? And the answer is yes, because 4, we can take our 4 times 3, which is 12, and our 1 times 3, which is 3. So 1/4 is equivalent to 3/12. And if we were to decompose that tape diagram into 12ths, because we times it by 3, each of our 1 units is going to become 3. So I'm going to put 2 lines. So now I have 1, 2, 3 12ths. 1/4, 3/12. So I'm going to rewrite that addition problem up here. So it's going to become 3/12 plus 1/12 is equal to 4/12. Denominators staying the same. I'm adding those numerators. After you draw that tape diagram, if we were to add those together, we'll have 3, 4. 4/12. All right. Okay, so let's see what this is going to look like instead of a tape diagram if we use a number line. All right, so our first problem here is going to be 1/2 plus 7/8. I'm going to show you what this would look like if we were to use a number line to help us solve. So I'm going to draw my number line out. Got 1, 1/2, and 0. And because my 1/2, actually we're going to do this. This is going to be 1, 2. Here's my 1/2. Okay, so if I want to decompose this into 8s, I can also do that. I'm going to do that in smaller lines across between our 1 and our 2. So I know that this is my halfway mark. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. And then halfway. And then 1, 2, 3, 4, 5, 6, 7, 8. Whoops. 1 extra. Okay, so my little hash marks are equal to 8s. 1/8, 2/8, 3, 4, 5/8, 6/8, 7/8. 1 is equal to 8/8. Okay, so if I'm starting at 1/2, I'm going to put my little marker there, and I'm going to add 7/8. Okay, so if I go 1, 2, 3, 4, 5, 6, 7. So I just added 7/8. So what did we land on? Well, I know that 1 is equal to 8/8. So there's 8, 9, 10, 11. 11/8. Okay, and remember we can convert that, or we can just look at this and say, well, here's 1. So there's 1 and 1, 2, 3. 3/8. Okay, so we can use that number line. You can break the number line up into different units. If we had halves and 8s or halves and 4s, then you can still show that kind of like a tape, oh my goodness, a ruler. How a ruler has multiple marks on it, and it's broken up into different, sorry, I just bonked my camera. And it's broken into different units. We can do that on our number line as well. Okay, so this became 1/2 plus 7/8. If we were to convert this to 8s, we would take it times 4 times 4, which would have been 4/8 plus 7/8 gives us 11/8. Our improper fraction, we convert it into a mixed number. All right, let's do one more with the number line. Okay, so here's our next one. We're going to take 2/3 plus 3/6. Draw my number line out. I only need to go to 1 for this one. Okay, so first I'm going to represent my thirds, 2/3. So I've got, I'm going to ignore, here, let's take that off just for now. It's easier to see where I'm going to break it up into thirds. So here's 1/3, 2/3, and then 1 is equal to 3/3. So if we want to write it that way, we could. And then 6, we're going to break it into 6. I'm going to find that halfway point. Half of 6 is 3, so that would be 3/6. And then we would have 1, 2, 3, 4, 5, 6. So these bigger marks we can think of as our 6. And if you want to use different colors, that's a little bit easier to tell the difference between them. All right, so here's 1/3, 2/3. I'm going to add 3 of those 6, 3/6. Okay, I messed up that number line, so we're just going to skip over that for this one. Thirds and sixths are a little bit too complicated. I want to show that to you guys in person where I can do different colors. So 2/3 plus 3/6. Let's just work on converting our thirds into sixths. Okay, so if I take 2/3 and I want to change that to 6, well, 3 times 2 gives me 6. Remember, whatever I do to the bottom, I need to do the top. So my 2/3 is going to become 4, 6 plus 3, 6. 4 plus 3 gives me 7, 6. And our 7/6, we notice is that improper fraction. So if our numerator is larger than our denominator, then we can make one whole. So if I take 6 of those 7 and make 1, so if I take 6, 6, that's going to leave me with 1, 6. So I can rewrite 7, 6 as 1 and 1, 6. Okay. So we'll do a couple more just with converting without a visual. All right, 4/5 plus 7/10. So if you want to draw an area model or, a tape diagram to represent it, you can, or a numbered line. We're going to work on just what does this look like if all we're going to do is find the connection between our denominators. So our denominators are 5 and 10. Can I convert 5 to 10? Using multiplication? I can. So if I take 5 times 2 and 4 times 2 and solve those and rewrite it, so 4 times 2 gives me 8, 5 times 2 gives me 10. So 4/5 is equivalent to 8/10, and now we can add that to our 7/10. Denominator stays the same as 10. 8 plus 7 gives us 15. 15 is larger than our denominator of 10. So if I take 10 of those tenths, what does that leave us with? So 15 minus 10 is going to leave us with 5 tenths. 10 tenths is equal to 1, so we can rewrite this as 1, and we still have those 5 tenths. Okay, so the visual model isn't a necessity for you guys to solve these. If you can find that relation and figure out what you need to multiply by, then that's to me, it's easier if we just do the math. Okay, but the visual models will help you see what's happening when you're doing that. All right, let's do one more, then we'll call it a day. All right, so last one of the day is 4/6 plus 1/2. So let's look at our denominators. Are they related? Can we change one to be the same as the other? Yes, we can. So 2 we can change or convert to a 6 using multiplication. So we're going to take 2 times 3, and whatever we do to the bottom, we do to the top. So let's rewrite that with our solving with the multiplication. 4/6 is going to stay the same. My 1/2 is now going to become 1 times 3 is 3, 6. Denominator stays the same as 6. 4 plus 3 gives me 7. Numerator's larger than the denominator, so let's take 6 of those to make 1. 7 minus 6 leaves us with 1, 6. So 6/6 is equal to 1, and we still have that 1, 6. 1 and 1, 6. All right. So small groups this week, we'll keep working on this, and then next week we'll get to work on this in person. So that's exciting. So if you guys have any questions, make sure to pop into office hours, and we will continue to work on this. Have a great day.